Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
Welcome back, team. And yes, our goal is to deploy our application in the Kubernetes cluster and access the application from your public internet browser, right? That's how I would like to ensure that the whole application is running in the Kubernetes, right? And we are doing a lot of improvements in the practice of how do we run a application in the Kubernetes cluster, how do we deploy all the different things, right? And definitely our goal is not to just deploy in the Kubernetes. We need to deploy the application it into a environment specific, right? Start from the dev towards the production. So to make this happen, right? Yes, there are significant challenges, and now we are going to introduce the concept of HELM, right? So already given some context, why do we need to use the Helm, correct? So at some level of recap, right? So whenever you wanted to deploy a application in the Kubernetes cluster, we have already realized by now that you need to depend on multiple manifest files to ensure that the application is successfully deployed and accessible from the outside world, correct? Just to call out, it can be a manifest of the horizontal pod autoscaler, could be a deployment, could be a service, could be a ingress, or could be a the service account, like that. The list will keep on going, right? As in when I introduce few more concepts, right, this list will go on because every resource will have its own manifest file and we need to deploy that, correct? So one problem is when you have multiple manifest files, right, it's very hard for me to manage the bunch of multiple manifest files to ensure one single application is successfully running with all the best practices like high availability, scalability, all these things, right? The second problem is managing that deployment it into a environment specific, correct? And we have seen that right sometimes I need a replica count 1 in dev, I need a replica count 5 in production. How do you ensure that, right? The same application, I hope you are following, right? When I say same application, it's the same image, right? The same Docker image that I wanted to deploy it into multiple environments, but it will be a different configuration. Of course, we will be deploying it into different namespace, but I'm now pretty much focusing on the configuration, right? The dev, it should run with one processor. In production, it should run with 10 processors, as an example. That kind of the configuration that I wanted to make it unique in each and every environment. That's where, how do you ensure that you are passing the specific values? That is where the Helm will help you to make your values that you are giving in your manifest files as a variabilization. Whenever you are using the Helm concept in order to get the advantages of the two advantages that I called out, right? The Helm is expecting that the manifest files that you are expecting the Helm to be managed, those manifest files should be given to the Helm software in a proper directory structure, right? So if you look into this screen at this time, I have a folder called helm-sample. In that folder, I have certain specific hierarchy, right? So we can see a folder called templates. Under the templates folder, you can see the actual manifest files that I'm expecting the Helm to be handled. This is the standard structure, guys. If you give your manifest files by keeping them in the templates folder, then only the Helm will take it and will process it, and it will do the needful for you. So you must be keeping your manifest files inside a folder. The folder name always be a templates, and that folder should be in any other, the parent folder, right? So whenever you maintain this directory hierarchy and keep your manifest files in the templates location, you give this whole directory, like I will be giving this helm hyphen sample folder, right? This folder is containing my whole stuff. This folder I'm giving to my Helm software. The Helm will now look into your folder and all the subfolders and the files in the template, everything. It will be packaging them it into one single file, right? No matter how many files that you are keeping in the templates folder, in the presentation I'm showing only two. It could be two or it could be any number, right? It will take all of them and it will be creating a one single file for you, which is now called as a Helm artifact, which is also called as a Helm chart, right? The .tgz file that it has got created, right? This file is now called as a Helm chart. What is the Helm chart now? The Helm chart is one single packaged formatted file which includes all of the manifest files that you are expecting to be. If then, right, you don't need to worry about managing multiple manifest files because all of them are packaged it into one single file. Now you take this Helm chart and start doing the deployment it into a target Kubernetes cluster wherever you want, expecting the deployment should go on. The Helm will take care of how to extract the Helm chart and how to deploy the manifest files in the Kubernetes. That portion will be taken care by the Helm. Good. So if this is the case, right, just to call out one more time, right? So if I ask you, hey, could you please deploy a application in the Kubernetes cluster? What is that you would be required now? You just need a Helm chart. But can I say this statement? You can deploy a application in the Kubernetes cluster using the manifest file or using the Helm chart. Both are possible. Agree? Right? The Helm is just another open source software that I'm using here just to make my life easier, nothing much. At the end of the day, from Kubernetes perspective, do you think the Kubernetes will worry about the Helm, or do you think the Kubernetes will, will be understanding at least how the Helm is working? No, right? The Kubernetes always need a manifest file to process it. Getting me? That means the API server that is running in the Kubernetes control plane, the API server always expecting the file to be a manifest file only. The Helm is just trying to make your files it into a package format. And again, when it comes to the deployment, right, your .tgz file will be get extracted, will get a actual manifest files, and only that manifest files will be get deployed it into the Kubernetes. Getting me, guys? That means your Helm chart will not go and your Helm chart will not be given to the API server directly, no, because your API servers cannot understand the Helm chart, right? The API server always need a manifest file only. So in between, the Helm is just preparing a chart, and again it will extract it and it will create a manifest file out of it, and it will give the manifest file only to the Kubernetes when it comes to the deployment. Then why do I use the Helm? Just to make your life easier, because it supports merging all the files or bundling, creating a bundle of multiple files into one file, and also it will help you on the variabilization as well. That's how it is. Super. If then, how do I get started with a Helm? Okay, we'll see that scenario now. So I have the Kubernetes cluster ready, and let me create a kubeconfig file in my Kubernetes client so that I can start interacting with the Kubernetes. So I'll run AWS EKS update hyphen kubeconfig, the name of my cluster, and it is on US East 1 region. Good. Let me verify this now. kubectl get nodes. This is working. Now I wanted to deploy my application using a Helm chart, right? In my Visual Studio Code, already there are some Helm charts that I have prepared in order to do the deployment, right? And I can see my, my deployment manifest file, and I can see my service manifest file. Now I just need to deploy them as a Helm chart, not as a individual manifest file, right? So let me take you to the Helm documentation first. So if I go to the helm.sh website, which is the official portal where the Helm is having their stuff, in the helm.sh, if I go to their documentation under the chart section, you see that the Helm package is called as a chart, and always your folder should be in this hierarchy, guys. This is the directory structure, how it's supposed to be in order to generate a Helm chart. This structure is pretty standard. You need to follow this structure in order to prepare your manifest files. And you will be getting one top level directory. Under the top level directory, you should be having a folder called templates. Under the templates, you need to keep your manifest files. Now you will be having one more file called chart.aml. That file, you need to keep the details of the Helm chart, how you are expecting the Helm chart to be get created. In the sense, what is the Helm chart name that you are looking for? What is the Helm chart version that you are looking for? Right? That kind of the information that you need to give in the chart.aml file. README is just informational, right? You just need to mention some documentation kind, like what is this Helm chart? Why do we need to use this Helm chart? Which application that you are trying to deploy, you just put some information in the README so that right, your colleagues can easily understand what this is all about when you are working on it, right? So as I said already, that the Helm is making your manifest files as variabilized, right? If we are using the variabilization concept, the values, right, the values that you wanted to supply, all the values will be in a values.aml file, right? So this is the file where you need to keep the values that you wanted to supply to your Helm chart. And for now, don't worry about what is this schema.json and what is this CRDS, which are optional, which we don't need to worry at this time, even the chart folder also. So this is how we need to prepare a Helm chart directory structure, and then we'll go with that. For now, let me try to create this structure, guys. Okay, and you can see some more information as well below. What will be the format of chart.aml? You see that in the chart.aml, you need to define the data in this format. One good thing is the Helm is following the AML syntax only, right? And you see that it is following the AML syntax only, like how you are following the AML syntax to define a manifest file. The same way the Helm is also following the AML syntax, and we just need to go with that to prepare your Helm structure, right? So let me show you that. So I don't know if I have the Helm installed in my local system. Let me try that. I'm just trying to see the Helm software is installed or not. Look like it is there. Okay. So in order to work with the Helm, right, you need to download and set up the Helm software in the development system where you would like to run the Helm command to create a Helm chart, right? So you can go to this helm.sh and try to download the Helm chart software. So in the documentation, you can see that installing the Helm, and this is the page that it tells you how to install the Helm, and you see the steps here, and just go to this desired version to see or to download the Helm software, right? And here you can see the Helm software, which is the latest version is 3.14.0. Now here you can see the Helm software available for different platforms, which machine that you are using as a development system in order to doing your development stuff. When I say development, you're preparing your Helm chart, manifest files, all these things, right? Accordingly, you go and download the corresponding software here, right? If you are using a Windows, you just download the Windows one. If it is a Linux, just try to use the Linux stuff. That's how it works, right? So in my case, downloading and using the software is pretty easy, guys, right? These are just binaries. For example, if you download any one, right, maybe Linux one, I'll just take a Linux AMD 64. If you click on that, you see that it is actually downloading the Helm software in the tar.gz format. We just need to extract it and start using this. Probably I'll show you how to set this up in the Linux system. So I'll just click on right click here, copy the link from where I wanted to download the Helm software. I'll go to the system where I wanted to use the Helm. Now duplicate is the command in order to download a software from the HTTP links, and specify the link from where it has to download the Helm software and hit enter. So the duplicate will be downloading this file from this HTTP web link to the present working directory. In the present working directory, now I can see that the file is downloaded as a tar.gz format. So which is like gz is like a compressed format or the GIF format. Tar is a kind of the archival format. To start using this, we need to extract it, right? So to extract this file, the command is tar-zxvf. Tar is the command to extract it, like kind of a GIF format, just for understanding, right? And specify the file name that you wanted to extract. So now you see that it is actually extracted and created a folder for you here. Go inside that folder. That is where you can see the Helm software. See this? This is the Helm software that you need to use now in order to create a Helm chart, deploying the Helm chart, whatnot. So since this is a binary, right, currently I have downloaded and extracted it into the specific folder like this, right? It's always the best idea to keep any binaries, right, which will be using as a commands, right, it into a standard location. So now rather keeping it in my this slash root location, right, I'm just moving this file it into slash usr maybe bin location, right? Because that is the standard location where all the commands will be there. I'm just trying to put that it into the same location so that you don't need to be in the same present working directory. You can be in anywhere. For example, I've just back to a different location. Still your Helm command should work. Let's say Helm hyphen version, Helm version. You see that now the Helm command is working, and this is the version that we have currently installed and set it up. Good to go. Now, in order to start working with the Helm, right, I would say that Helm create and specify the folder name. Let's say a web application, right? Whenever you run the Helm create command, it is going to create a folder called web app. You see that here. Probably in this present working directory, right? I have many files which I'm keep on working in the previous lectures, right? Maybe best idea to go with a different folder where I don't see any of the other files, right? It's easy to work only on the Helm concept, or else why unnecessary I'm keeping these files in our discussion, right? You got me what I'm trying to? So let me delete this. What I do is I'll just create one temporary folder. Maybe I will say mkdir slash K8s practice. The only reason is right now it's like empty directory. It's very easy to focus only on the Helm, not on any other files, right? What I can run, right? Helm create and let's say web app. This command will be creating a folder, the folder name, that one which you have given in the Helm create command, right? Now, if you go inside the folder, right, you see it has automatically created a required directory structure. I was keep saying that it has its own directory structure, right? Now it has created a very mandatory files and the directories that's supposed to be in your folder. It has a chart.ml, it has a templates folder, it has a values.ml, it has a charts folder as well, right? Now you start putting your manifest files in the templates folder. We'll do that now, right? So first I'll go to the templates folder. This is where it is expecting the manifest files to be. And you see it has some default sample manifest files for you. Deployment, HPA, ingress, service. Pretty much these are the mandatory manifest files to deploy any application, right? So it has given you some sample so that it's easy for us to understand the structure, right? But we can develop our own, right? So what I do is in the templates folder, I'm going to remove everything because I just got some sample, but I have removed everything. Now I'll start putting my own manifest files there. Okay, so let me start putting some manifest files first here. What I do is I have the manifest files already with me, right? So this is for deployment, right? So I'll take this file, right? I'll take this file and I'll just try to put here. I can do all these things in the Visual Studio Code only, but I felt right uh, do it from here only. That's okay. So this is the deploy.ml file. So this is my deployment file, right? Now let's say I wanted to use the service definition. Service.ml file. Done. That's okay. Just for understanding, right? The two files are fine. It could be two files or five files. What doesn't matter any. Uh, doesn't makes any difference here, right? Now, um, where I am exactly, guys? In the sense, currently I have logged into which server? Just to give you a question here, right? What could be your answer now? In which server currently I'm running all these commands? This is the Kubernetes client, right? This is not a worker node. Why do I need to logging into the worker node? Just for looking into the chart window, right? I will never ever log into the worker node. I don't need to. Anything that I want, anything that I'm expecting in the worker node, I will just talk to my API server only. API server will do it for me on the worker node, right? This is just a client. Whatever I'm doing on my putty, which is the client, I can do on my Visual Studio Code also, right? Here only I can create a Helm folder. Probably I can run one command as well here, right? So Helm create web app. So that will be creating a folder for you. Sorry, I need to come to the same directory. Right. So Helm create a web app, right? So here I can see that the web app folder is got created with all the Helm chart directory structure. This is just a development that I'm doing, right? Now under the templates folder, I can see the multiple default files just to help you how the structure has to be. For now, what I'm doing is, I'm going to delete all these default files that are got created in my templates folder. I'll just keep my own files, right? Done. So now in the templates folder, nothing is there. It's an empty one. Now what I do, right? I'll try to put my own files. Under the templates folder, I'm creating a file. First, the one is deployment.yaml file, and I'll keep my deployment manifest file, which is handy for me. Done. Now under the templates, now I can do a one more file called service.yaml file. So this is my manifest file, right? I'll keep it there, right? So I think all other files that what you see here, right, which is makes confusing because we are just focusing on the Helm chart. What I can do right for now, just to make it more clear, uh, these are the old files because I have used all these files for practicing, right, the previous concepts. So what I do is I'll just moving these files it into a folder called old so that it's clean now. It's clean, right? Now you see that I'm currently focusing on the web app folder. That is where I'm trying to prepare my Helm charts, right? Now the templates folder has my deployment manifest file and the service manifest file. I'm done with my templates file. Now in the chart.yaml, right, you need to specify the chart version that you are trying to create, right? So in the chart.yaml, you need to specify the name of the chart that you are trying to. This is the chart name. The description of the chart, why the chart is all about. This is to deploy a web application, right? And let us scroll down the version, which is the chart version that you are trying to. So usually, right, the Helm chart versions will be having three levels. The first one is called as a major version. The other one is called as a minor version. The other one is called a kind of a suffix, right? This is how the people will follow the versions to identify the Helm charts. Because today I'm creating one chart. Tomorrow, when there is a change, right? Again, you need to do a modification. That will be called as a second version, third version, fourth version, right? That's the reason we need to go with this, right? And the app version, right? This is one other. Uh, this app version is about your application version. Both are different, guys. The version is the Helm chart version, and app version is your application version. That means your Docker image version, kind of. But this is just for our meaningful, for our understanding. There's nothing, there is no rule that this number should be always so and so. No, this is just for our understanding to know which version of the software that we are deploying it into our platform, because we'll be keep on modifying the stuff and we'll be keep on increasing the versions, correct? The other day I was showing you, right, when you deploy the v1 version, which is the old code, later if the code get changes, you'll get a v2 image, right? The second version, right? So that we need to build it again. That's the reason every time when I do change, we'll keep on increasing this 1.0, 1.1, 1.2, 1.3, so on, so on, so on, so on. For now, I'm not worrying too much about the version. Let it be, right? Now, this is my Helm chart version. This is all optional. Let it be. The things that I need to focus here is the Helm chart name and the Helm chart version. Only these two are the mandate. Rest everything is just for our informational purpose only, right? Now, I see an interesting question in the chart window, right? How did I move the files? It's just a drag and drop, guys. I think you are working on this VS Code since long, right? Drag the file and keep it wherever you want it to, right? That file will go there. That's it. Okay. Anyway, now I'm done with my templates folder. I'm done with my chart.yaml file, and this is the values file. In this value file, you need to specify the values that you wanted to pass for your deployment. This is the sample values file that is prepared for you in order to understand how the syntax will be. But for now, let me remove everything and I'll show you from scratch how do you prepare the values file here. So you all know, right? Why do I need to worry about the values? Because I wanted to supply the different values for each environment, correct? When I'm deploying this into dev, it should run with a different capacity, and in other environment, it should run with a different capacity. That's where we need to tweak the values at your values file, correct? But before you go and give the values in the values file, right? Probably in your Helm charts, right? Sorry, probably in your manifest files that you kept it in the templates folder. In the manifest file, first you need to decide which value you are expecting it to be changing from environment to environment. Agree with me? Let's say if the value is not changing from one environment to another environment, do you think that that has to be variabilized? Of course, you can variabilize any value that we like it, but in general, if you think that the value is pretty much same in across all the environment, you can make it as hard coded. Whichever the value that you think that it has to be variabilized, it has to be changing from an environment to an environment, then you make that as a variabilize. That's a general practice. But if you ask me what is the best practice, the best practice is you make everything as a variabilize, right? You make everything as a variabilize. So down the line, whenever you wanted to give a different value, you can always, you don't need to change your templates again and again. But for now, let's say I'll focus on few values. Let's say the replica count, I wanted to change from a dev to the production. I want to make this value as a variabilize, not as a hard coded. Okay. So now let me make it as a variabilize here. So in order to variabilize, right, the syntax will be like this. Dot values, right? Dot values dot and specify the variable name. For example, this is a replica count, right? So this is the replica count. So this replica count, let's say, yeah, I think this is good. So this is how it is. So this syntax says that, hey, a replica count is the variable, right? A replica count is the variable. Where is this value, guys? This variable value, you get it from the file called values.yaml. So dot values, this syntax tells that, or the dot tells that get the value from the present working directory from the values.yaml, which is the kind of a, technically we call it as a root, right? The dot refers root in the sense, in this case, there is a file called values.ml in the same location. Go to there and get the values. That's the meaning of dot values. I think new here, like if you go to Terraform, right, how do you represent to tell that to get a value for the variable? The syntax will be like var dot, right? Var dot and specify the variable name. That is the syntax to tell that, hey, this is a variable, you go and get the value. Similarly here, dot values is the syntax that we need to use, telling that replica count is a variable, get the value from the values file. Now in the values file, you define your variable and the value that you wanted to supply. I'm done. Right, in the same way, now let's say I wanted to prepare a variabilization for any other, right? So before that, let me confirm this syntax one more time. I think I got some samples here, right? Okay, did I remove everything? That's fine. So let me get a sample to understand the syntax better. Right, so here I can see the values how I'm the documentation says, and this is the values, and you see here this is how they are using dot values dot and specify the variable name, right? They have given some examples here to understand how do you, give the things. Okay, the pretty much kind of the concept of int and the string and how do you specify the values there, all these things. Okay, let me come back here. So I'm only worrying about whether it should be having any quote mark or not, because every programming language will have their own syntax, right? Sometimes it's hard to remember which is expecting what. So let me get one sample. Yeah, this is what I was looking for, right? You see, this syntax should be within the two braces. That is how I'm telling that inside these two braces, the expression has to be performed, and the corresponding value of this expression, which is your variable value, right, will be get rendered into this particular place, right? So that's where I was a little worried. So let me specify that. I got doubt because it was not giving me a proper color. Now good, right? So this is the syntax how we need to specify that, right? This is a variable, please perform this as a expression, and it will get the value from the variable, sorry, value file, and the value will be get replaced. Now let me do the same thing for other things as well. I think I need to remove this node name, guys, because this node is not exist, right? This I have added yesterday just to show you how the syntax will be, right? So probably I need to remove the node selector as well. Well, I'm just going with the minimal and the template section, right? And the spec section. This is the name of the Docker image that I wanted to, sorry, this is the name of the Docker image and the Docker image tag that I wanted to, right? Probably now I wanted to specify the request as a variable is. So what I can do, right, specify the placeholder dot values dot, this is the memory, right? Specify memory over there. Now the same thing has to be repeated for my CPU as well. Let's say this is for CPU. Now you need to specify the values in your value file. So in a value file, specify that memory, specify that CPU. right? In the memory section, you give the value, let's say 1 MB. In the CPU, let's say I'll call out like 10 milliseconds, right? It should be EMI, guys, right? EMI, that is MBs. So the problem here is when you are trying to make them it into a variableize and give the values in the values file, right? The why I'm doing this case, at end of the day, I would like to make my manifest file as a generic, correct? The only reason why I'm making it into a variableize so that my manifest file will be a generic because the values are not hard coded. So tomorrow I can easily manage which value that I wanted to supply just by editing the values file, correct? So that I don't need to touch my templates. I don't need to touch my manifest files each time. Good idea. But in the values file, right, how do you understand what is this memory? What is this CPU? Getting me? So just by looking into one variable, right, it's very hard to understand, right, this, let's say, if I'm changing this memory value, this value is getting impacted, will be getting updated in which section in your manifest file. It's very hard to understand all this, right? Hence the reason you better maintain a multiple hierarchy in your values file also. In the sense, you can specify that this is the deployment related values that I'm trying to manage, right? So you go with the deployment as a top level parameter. Inside that, you give the replica count. Under the deployment, let's say I wanted to manage the resources. Under the resources, right? Let's say I wanted to manage the request. You see, pretty much I'm trying to replicate the similar kind of the the hierarchy. That way, right, you can easily understand by looking into the values file. Okay, this is all the deployment related configuration, and this is the replica count that I'm giving for my deployment. These are the request limit that I'm giving for my resources. It's very easy to understand while you are actually editing the values in the value file. When you are managing this kind of the hierarchy, right, we need to tell the same hierarchy in your variabilization concept as well. In the sense, replica count is actually under the deployment, right? So in the deploy.yaml file, wherever you have mentioned the replica count, you need to tell that, right? The value you can get it under the, what happened? The value that you can get it under the deployment, right? Go to the value.yaml file. First, you look for the deployment. Under the deployment, you look for the replica count and get the value and replace here. That is how we can mention the level as well, like the multiple levels if you have maintained in your values file, guys. That is just represented using the dot notation, right? Now, in the same way, if I come to my memory and CPU, right? In this case, you see the memory is part of deployment, under that resources, under that request, correct? We need to maintain the same here as well, right? So under the value file, go to deployment, go to resources, go to request, then get the memory, and that value has to be rendered here. And the same thing will go for CPU, and it will be CPU. That's how we need to work on. The same way, let's say I wanted to manage my limits as well as a variabilization, right? So in the value file, you define like this: limits, under that limit, memory and the CPU. Make sense? Now you specify this particular variable, right, in your manifest file here. So I'm just copying this right? So under the resources, under the limits, get the memory, under the limits, get the CPU, like that, right? So like that, you define all uh, the, the, the values, right, as a variabilization, and keep the values in your values file. That way your template, I mean to say your manifest file will be a generic. I hope this is good enough. I don't need to go and make the variabilization for all other values, right? The same way we need to manage making everything into a variabilization concept. The same way, let's say now I'm trying to make my service file as well as a variabilization. Let's say the target port, I wanted to make it into a variabilization, right? So let me do this. Dot values dot, let's say this is the target port. Which target port? This is a service target port, right? Maybe I'll do service dot target port, so that in your values file, right, now you define this, because I said go to the values file and get the service under that service target port. So in your values file, it should be like this.
Hey, Pierre, I have a doubt.
Yes, please.
So, like, let's say there are four namespaces, okay? Dev, prod, val, QA. So that means in the values.yaml file, you are going to make changes four times. Like every time you're creating
We'll
new
do that now.
deployment.
Yeah, we'll do that now.
You understood
Right.
what I try to mean? Like how can we avoid that four times
Mhm,
editing?
We are doing that. Okay.
Okay.
Uh, yeah. So this is how you maintain the levels of the values, and you compose it in a proper way, and try to keep that into your manifest files and make them into variabilization. So far, so good. Like that you do for all wherever you wanted to make it as a variabilization, right? So that way my manifest files are ready as a template format, because the values are not here, and that's the reason your manifest files should be under the templates folder, because now these are actually templates. Why it is template? It has a generic, get the values from outside, right? Now, so the chart.yaml has the chart details, and the values.yaml has the values, right? Now the the top that you see, the chart folder, right, this is a empty folder, and we'll talk about this later. No significant importance for this folder for now, right? Now my requirement is this entire web app folder. I wanted to create it as a Helm chart, right, which is in the .tgz format, right? So the values file, right, I don't want to be a part of my Helm chart. This values file to be outside, because right, the values file to be supplied every time when I'm trying to do the deployment. The only thing that I'm doing here is I'll take out this values file not to be in the same folder. I'll make it separately, right? Probably I'll have here one more folder just to understand the concept. So the values file is now in the different location altogether, right? So the web app folder is now containing only the chart.yaml and the templates, and it has a generic syntax to telling that get the data from the values file. But this web app folder does not have a actual values file. Makes sense, right? Because I don't want to keep the values in the same template, right? So now can I say that the web app folder is containing only the Helm charts, sorry, only the manifest files as a generic template without having any values, correct? Now this web app folder, I'm going to create it as a Helm chart. What I do is I'll run the command called Helm package and specify the folder name in which folder that you have kept your manifest files as a template format, and just hit enter. This command is now creating your web app folder as a Helm chart. You see that web app -010.tgz, right? This is called as a Helm chart. It is picking the Helm chart name, the Helm chart version from your chart.yaml file, and it will automatically generates the Helm chart for you. Now, can I say that in this .tgz file, right? This file has all the manifest files that I wanted to deploy as a generic template format, correct? Without having any values, right? This file has the manifest files without any values so far. So now if I ask you, hey, can you deploy the application it into a dev? So I will be using this Helm chart to deploy it into the dev. So can I use the same Helm chart to deploy it into a production as well? Yes, right? Why? This Helm chart is currently having only the generic Helm manifest templates, right? There are no values inside it. Agree with me, guys? Right? In this .tgz file, there are no values. This is just a generic manifest files. Now, whenever you wanted to deploy this it into all the environments, now you supply the values. All what you need to do is prepare the values accordingly. Maybe you prepare one values file for dev. I don't want spaces, right? You prepare one values file for dev, and you make one other values file for your QA. Let's say this is for QA, right? And you make one more file for your other environment, let's say for production, right? So that means what? Whenever you are trying to deploy your application it into a different environment, right? What values that you are expecting for each environment, you prepare a separate file for that. Now you go to the dev file and you define how you are expecting the dev has to be deployed. You go to the production, you specify here how you are expecting the production should be. Let's say in the production, I need a replica count 3. Specify that. In the dev, the replica count 1, right? So like that, you mention your environment specific value file, which is a separate file. You are not going to edit the same file. That will be a big mess, right? You maintain a separate file and you maintain a separate values for each and every environment. When you are trying to do the deployment, let's say now I wanted to run my application, right? Now, before that, you need a namespace, right? Let me create a namespace, guys. So I need a dev namespace, and let's say I need a production namespace, because the deployment should go into the namespace, right? That's the reason I'm creating a namespace. You see, when I'm running the kubectl commands in my local system, right, it's taking hell amount of time, right? That is the reason I preferred the putty in order to run these commands, right? But putty is just a client, nothing much. So AWS EKS update hyphen kubeconfig hyphen name EDUeki EKS01, and the region is US East 1. It's a brand new cluster, so I just need to set up the kubeconfig first. Now let me try to create a dev namespace, then production namespace. Now all what I do is Helm install is the command to install the Helm chart, and specify the application name. I wanted to deploy the application called web app, right? And now you specify the file, which file that you wanted to supply, In the values folder, there is a file called dev-values.ml. So this file I wanted to use to get the values, specify the values, and specify the namespace, in which namespace that you are expecting it to be get deployed, and specify the Helm chart location. Where is the Helm chart? Let's say in my case, my Helm chart is in the present working directory, right? This is where it is. So I can just say that dot. That means, hey, in the present location, there is a Helm chart. Get that Helm chart and start doing the deployment. So here the web app, whatever I give, right, this is called as a Helm release name, right? The Helm should maintain the track, right? What is being deployed. So it is just a release name, right? So you can give whatever the name that you like it for this release. If you wanted to be very specific about the release, you can even say that, let's say this is the web app for dev. So this release is just a Helm level control, nothing to do with the Kubernetes. Kubernetes is never worry about your Helm. The Helm is going to extract the manifest files that are currently in the Helm chart that you defined here. Then it will get the values from here. The Helm is going to apply these values to the actual generic Helm charts, sorry, generic manifest files. Then the Helm is going to prepare the final manifests. Getting me? The Helm is going to prepare the final manifest, what could be after replacing the variables, the original manifest files with the actual values. So it creates that files, then those files will be get deployed it into the Kubernetes, because the Kubernetes API server will only accept the manifest file. Kubernetes will not accept the Helm chart, right? So the Helm chart is going to prepare the manifest files with the actual values that you have been asked for. Then the final manifest file will be given to the Kubernetes. That's how the Kubernetes will take it up and do the deployment. Now, how would the Helm is doing that? Do you think the Helm is connecting to the Kubernetes API server here to do this deployment? Right? And again, the the thing is the Kubernetes API server will only be connected by the kubectl client. The Helm cannot go and talk to the Kubernetes directly, no. Though you are using the Helm, behind the screen, the Helm is going to use the kubectl credentials only. The Helm is going to use the kubeconfig file that is available on this system there, right? It will just render the values it into a Helm chart, and then finally the Helm charts will be given to the kubectl. Kubectl only going and talking to the Kubernetes and supplying all the files for the deployment. Getting me, guys? That means at the end of the day, from the Kubernetes perspective, kubectl is the one who is actually giving the files and asking for the deployment. And here I'm just using the Helm as another extra abstracted layer, which is just making my life easier, because the Helm is actually doing taking the values, apply the values, make a final manifest, and give the manifest file to the Kubernetes client kubectl. That will be taken care of. Okay, so let me specify the chart name. So this is fine. It's just showing some error. Look like the format is little problem. So it says that the installation is failed and there is one error that is occurred. So Helm list is the command to see the Helm charts that are currently deployed, and as of now the Helm list showing that empty. Now let's see what's the problem. It says that in the deployment there is a issue and web is invalid in the selector. Let me go there in the templates in the deploy.yaml. I think we did some changes yesterday, right, for this deployment manifest file. What will be the syntax, guys? API version, kind, metadata, spec, replicas, and I think, do we need this? Template, metadata, yes. Under the metadata, the name, labels, spec section, it's all good. Tolerations should be in this level. Let me remove because we did not tested this syntax after it is been added. It won't work because I need to recreate it, right? So let me remove this Helm chart. Let me create it again because I made a change in my Helm chart, right? I need to create it again. So Helm delete web app-dev. Sorry. Helm uninstall and specify the release name because it tried some time back. Okay, is it deleted? Okay, let's see what will happen. So before that, I don't want any errors to be. Let's see. So Helm package and specify the folder name. I'm just trying to create a Helm chart again. I got the Helm chart created. Let me deploy this Helm chart one more time on the dev namespace. So installation file cannot reuse the name that is still in use. Let me use the different name, guys. In general, right, this Helm release name should be a unique. You can't use the same name, right? Somehow it is telling that that name is already in use. Let me use the different name. So what it says, kubectl get the service on dev namespace. You see in the previous installation, actually the services were created. So there is a partial deployment. kubectl get the deployment on the dev namespace, right? So it didn't do the deployment, but it has created a service and it is complaining that this service is already there because it is a partial one. The only problem is the Helm list should show that. Somehow it's not showing, right? It's not showing anything. Let me do the cleanup, guys. kubectl delete a service on dev namespace, right? So let me try to do it one more time. So let me change the name as well. Sorry. So under the spec, there is a selector. I'll go back there one more time. Under the spec, I don't see any selector here. It was there before, I just removed it and I saved it. I created one more chart out of it. So what is that it is referring, guys? Following me? So it's complaining that under the spec, there is a selector. The selector is empty. It requires a value. Okay. So, and under the spec, under the template, under the metadata, the labels is actually a invalid value. Right. And selector does not match the template labels. Just complaining. Just because of yesterday, I made some change and have not tested this up. Let me get the right one, guys. Well, so this is all good. Okay, so this is all good, and let me try to delete this Helm chart. I ensure that I save this file. Now let me try to create a Helm chart again. Helm package web app. Now let me do Helm install web app for dev-f. Under the values file, there is a dev-values file, and I want to use the Helm chart called webapp-010.tgjet, and this I wanted to deploy it into a dev namespace. Let me try this. This is annoying, right? So it can't take the duplicate names. kubectl delete a service my-service on dev namespace. Let me try now. Do we have anything like kubectl get the deployment on dev namespace? Just checking. Nothing is there. Let me try one more time. So it actually deployed now. It says that, hey, this is your Helm release name. This is the deployment when this is done. The namespace, the status is deployed. Revision is one in the sense you are deploying this at the very first time, right? So this looks good. And let me clear the screen. Let me run the command called helm list. So I'm trying to see the releases that is currently deployed, guys. Somehow this is empty. It has to show that, right, which Helm release installed, which in which namespace, which revision. It has to give the data. We'll come back to this command one more time. But for now, let's see if it is actually deployed or not. kubectl get the pods on the dev namespace. You see that it is deployed with one replica in the dev namespace. kubectl get the service on dev namespace. So you see that the service is also deployed. Now what I do is I'll try to deploy it into the production. I should be able to see at least 2 replicas. Why? I have the prod values file. The prod values file says that the replica count is 3, right? So the same application should be get deployed with the 3 replicas in the production namespace. All what you need to do is in your command tell that, hey, I wanted to deploy it into the production. The Helm chart is same, guys. I'm not changing anything in the Helm chart, but I'm trying to change the values file, right? So that it will try to deploy using the different values. And again, you change your, the release name, right? Now you hit enter. It is going to use the same Helm chart, but with the different values. Now, if you see kubectl get pods on the production namespace, it's running with the 3 replicas. kubectl get the service on the production namespace, and you see that the service is also deployed. That's how it works, guys. That means what? You put your manifest files into a Helm chart folder hierarchy and make your things variabilize wherever you want. You are expecting the value to come from values, right? And like that, you make your Helm chart as a very generic way and maintain the values separately and pass the values and the namespace that you are looking for, right, in the Helm command itself. So I was keep getting some errors, right? How do you troubleshoot the errors? What Helm is doing? The Helm will simply take your generic manifest file and it will go and get the values from the value file. It will replace this variable it into a actual value. Then it makes the final manifest file with the actual values. That file will be given to the Kubernetes. So Kubernetes will get the actual file that has to be deployed. That's it. Kubernetes will not see any Helm charts and all, right? So if you are doing any changes, any mistakes, right, in the variabilization or any other thing, right, in order to troubleshoot the Helm related syntax issues, right, you can use the command called Helm template. I wanted to use the values file called dev values.ml, right? And this is the Helm chart that I'm planning to deploy. You see the command, guys? This is Helm template, not a Helm install. Helm install will try to prepare a Helm charts. Sorry, Helm install command will try to prepare a manifest files and give it to Kubernetes. The Helm template will just try to take the values from this file, apply these values into the manifest files, and tell you exactly how the manifest files are prepared. You see, if you run this Helm template command, right, it is telling that, hey, it is telling that, right, so this is how the file will be prepared after the values are supplied. You see, your service.ml file, which is there in the templates folder, right, this file is now rendered using so and so values. The deploy.ml file is actually rendered using so and so values. You see, wherever the variable was added, right, that variable is actually replaced with the value that you supplied, and it is telling that finally this gonna be a manifest file that will be giving to the Kubernetes. That's how it works. If you made any mistakes, right, in the syntaxes or wherever it is, this Helm template command will not work, right? Then that will tell you, hey, this is a problem, right? You go and fix it, right? So for now, let's say I'm just doing some mistake here, right? I'm saying that this is the one. The replica count, I'm putting some typo. Now, if I try to create a template out of it, right? Of course, I need to create a Helm chart again, right? every time when you do a changes to your manifest files in your web app folder, which is your Helm chart folder, right? You need to create a Helm chart again. Helm package, specify the Helm chart again. Now you try to template it. You see, so this replica, right? You are not getting any value first of all, right? Why? That variable is not at a, this variable is not defined at, and it is showing as a nil value over there. So basically you run the template command, see if it is rendering properly, and you get the confidence that that will definitely work when we are deploying it into the actual Kubernetes as well. Now, so technically, right, it's not a good idea always you make your Helm chart as very generic without a values and you supply the values from outside. No, what you can do, right? You put a values file also in the Helm chart. You see that in the web app folder, I'm putting the values file again, right? In the web app folder, I'm putting the values file again, right? Now let me create a Helm chart again out of it. Sorry. Right, I'm going to keep the values file also in my Helm chart. So this time the web app folder has a values file as well, and I have defined some values here, how the values supposed to be. Now you create a Helm chart. What's the difference now, guys? The Helm chart has a values also this time, correct? Now I got a Helm chart. Can I say that this Helm chart is currently holding of the values also? Yes, right? It has a values too. But I don't want the values to be same in all the environments, right? But what we can do, right? Whenever you are deploying, right? Whenever you are deploying, if you specify any values file here, then the existing values, what were there in the Helm chart, those will be get overwrite with the new values that you have given. Make sense, guys? So you can keep certain default values in the Helm chart itself by giving some minimal values or whatever the values that you feel at least to be a minimal, right? Why? For any reason during the deployment time, right? During the deployment time, if at all you are not giving any values, let's say you are not supplying any values and you are trying to deploy the Helm chart, will it work now? Yes, it will work. Why? The values, some default values are already there in the Helm chart. Those values will be get applied and it will go proceed for the deployment. It will not give you any error, right? But if you specify any values here, then definitely it will take that precedence and these values will be get applied, not the actual what was there on the Helm chart already. So hence the reason, just to avoid some issues, right? Better you keep some defaults in the Helm chart and you override them as part of your Helm install command always. That makes more meaningful. Well, now there are different ways how we can tweak the things, but this is to get start with the Helm what it is. And yes, it is possible to give some command line arguments as well explicitly, not through a file format. All these things will be possible, but whatever the value that you pass on in the command line will take a more priority, more preference than the default whatever was already there in the Helm chart, right? Being said that, now if you wanted to deploy your application in the Kubernetes, all what you need to have is the Helm chart, correct? You just need a Helm chart and the values file. These are the only two things that I would need to deploy it into a specific namespace. Of course, the values file is just if you wanted to override something, because the Helm chart already has some default values. If you don't like the defaults, then you put your own values file and give that takes the highest preference. So the ultimate goal here is to have a generic a Helm chart that I wanted to use for the multiple environments. So that way you are not maintaining the separate manifest files for each and every environment. You only maintain the separate file only for the values only, right? Something like this. Make sense? Now let me try to run this particular slide, guys. I wanted to talk about the Helm a little more. Okay, so I just prepared this slide some time back only. Just to summarize the things, right? My goal is I wanted to deploy my application into the Kubernetes cluster. So you will be getting the code from the developer, correct? At the end of the day, when you are working as a DevOps engineer in the company, right? The developer will write a code for your website. The developer will give you the code. Hey, DevOps engineer, this is the code that I have written for my website. Could you take care of now how to run this code or how to deploy this code into the Kubernetes and run it as an application, correct? Getting me? So what is that you do, guys, whenever you get a code from a developer, correct? So whenever you get a code from developer, right, first you need to get into the build server, correct? You get into the build server, you try to create a Docker build, correct? The Docker build will try to prepare a Docker image. In the Docker image that you are creating as a customization, right? The Docker image has everything, whatever is needed to run the application. It includes the code as well. Following me? That's what I did it before, right? I actually created my own custom container image, which is including the code as well, along with all the dependencies, so that the image is ready. That image usually you publish to the Docker Hub registries and keep that image over there. That image now I wanted to deploy it into the Kubernetes. To deploy the image in the Kubernetes, I'm trying to prepare a manifest file, right? So, but now again, I'm not going through just a manifest file, right? I need to create a Helm chart out of it, correct? So now you put some time on the build server again, start preparing the Helm charts. Once the Helm chart is ready, that Helm chart now I wanted to deploy it into the Kubernetes cluster, right? So whenever you prepare a Helm chart in the, like pretty much you are doing everything in the build server, right? The build server is the server where you are actually preparing your Docker images, keep them into Docker Hub, right? Prepare a Helm chart and keep the Helm chart ready. You are doing this whole stuff in the build server only, right? So once you prepare the Helm charts, right, we need to keep the Helm charts somewhere in order to use that later, correct? Getting me, guys? Let's say today I created one Helm chart, right, on my local system, right? Tomorrow I wanted to use the same Helm chart to deploy it into my Kubernetes cluster, where the Helm chart is supposed to be stored, like a Docker image. In the build server, you create a Docker image. Will you be keeping your Docker image in the build server itself? No, right? Why? Why? The image has to be there in the somewhere in the remote repository so that whenever you want it, you go and get it from there. It need not to be a public repository, it can be a private as well. But ideally, whenever you prepare a artifact or a Docker image, don't keep it in the build server. The build server may get deleted or the build server may get destroyed, terminated after the build is completed, correct? I don't want the build server to be running for long, correct? So today maybe I wanted to do the build. That means I got the code from developer. What do? You go to the build server, you get the code, you prepare a Docker image. Once the image is ready, you put it into the Docker Hub, use it later. Correct? That's what I did it. Do I need to keep my build server up and running? No, right? No more needed once the build is completed, because whatever I needed for running my application, it's already there in the Docker Hub. My image is there. Same way, whenever you create a Helm chart, because I need a Helm chart to deploy it into the Kubernetes, right? That Helm chart has to be get published into a remote repositories. Where do I need to store this Helm chart? The Helm chart has to be get stored it into a server called JFrog. JFrog is the artifact management tool. JFrog is the artifact management tool in the sense the JFrog is well expertised in terms of storing the artifact of your Helm, which is your Helm chart in a way, right? The the way how you are keeping your Docker images in the Docker Hub, same way the Helm charts that you are creating, all those Helm charts that you are uploading to a JFrog server, the JFrog is going to store them. So that once you prepare a Helm chart in the build server, once you upload the Helm chart to the JFrog, later you just destroy your build server. You don't need a build server anymore. Why? The required Helm chart is already there in the JFrog. Whenever you need it, you go and download it from JFrog and run it. Agree with me? Right? That's how I'm going to keep all of my Helm charts that I'm preparing into a JFrog server. How the JFrog is working, right? So just think of like JFrog is like another EC2 server, okay, where the JFrog software is actually, where you actually uh, install the software on the one of the EC2 server, right? So let's say take a EC2 server, you download and install the JFrog software over there, right? Then that EC2 server, I'm calling it as a JFrog server, which has its own local volumes are attached, right? So in order to keep your Helm chart in the JFrog server, right? In the JFrog, you need to create a repository. Repository in the sense a kind of the virtual folder. Hey, in this folder, I wanted to keep my Helm charts. Just create some folders, right? The folders that you are creating in the JFrog server, those are called as a repositories. Just a technical terminology, right? Just kind of a folder only, but from the JFrog language perspective, we call it as a repository, and we call it as a local repository. That's the official term that we use. That means, so I take one JFrog server and I'll create one local repository, right? And I'll try to keep my Helm chart it into that local repository. Whatever you put that into a local repository, that actually store it into the volume, whichever the volumes are attached to your JFrog. You can create multiple local repositories that if you wanted to. Why? Let's say I have total 10 websites that I'm trying to manage. I have total 10 websites that I wanted to. Each website has its own set of code. Each website has its own set of Docker image. Each website, it has its own Helm chart, right? That means if I have 10 applications, right? So each application has its own set of artifacts. So it's up to you. You wanted to keep everything into one single local repository, or you wanted to make them it into separated it into a different local repository. It's up to your thought process. Anything should work. Sometimes the companies will just try to make a separated, right? Hey, all these application related Helm charts should go to one Helm chart, one local repository. All other applications should go to another local repository just for segregation something, right? But it can be one as well. So somehow you prepare a Helm chart and you push that it into a local repository of your JFrog that will be storing all those stuff. After that, once your Helm chart is there in the JFrog local repository, right? Like deploy is the terminology that we use here when you are uploading the Helm chart to the JFrog, right? So what is that? Our next step, guys. Once the Helm chart is in a local repository, what is my next step? I wanted to use that Helm chart to deploy it into the Kubernetes, right? Whenever I wanted to later time, correct? That's the only reason why I'm keeping them into a JFrog. Agree? So if I'm creating a Helm chart today, right, I may be using this Helm chart later down the line. Whenever I wanted to deploy, right? So whenever you wanted to deploy your Helm chart into the Kubernetes, how will you be deploying that, guys? You need to run the commands on the Kubernetes client software, correct? So you get into one of the Kubernetes client EC2 instance or Kubernetes client. It can be your local machine as well. Right? Don't get confused. Any Kubernetes client wherever the kubectl is currently installed and having an access to the Kubernetes, right? So go to the Kubernetes client, right? And in the Kubernetes client, you need to download the Helm chart from the JFrog, and that Helm chart you need to run a command and install it into a Kubernetes, correct? Are we good with this? Nothing new, right? Previously, when I was working with the Docker, right, you push the Docker image to the Docker Hub registry, and whenever you want it, you run a Docker pull and pull the image and run it as a container, right? Similarly, here I'm using the Helm chart now. The Helm chart will be publishing to the JFrog. Whenever I need a Helm chart, I'll just download it from the JFrog and run the command. That I'm doing it from my kubectl client. The thing is, if I wanted to download the Helm chart from the JFrog, right? How do I know that the Helm chart is there in which local repository? You got me? If we have multiple local repositories, right, as it is allowing us to create a multiple repositories just to make some isolation or separation, just to organize the things, right? Just to give a non-technical example, right? Let's say you have some 100 movie files. Rather putting all of them into one folder, you better try to keep them into a different folders by giving the proper names, right? Based on the category of the movies that you have, just for better management, right? So same way here, I can have multiple local repositories as well. But when I'm trying to download, right, how do I know in which local repository my Helm chart is there? That's the reason the JFrog is giving the concept of virtual repo. So in the JFrog, we create a one more repository called as a virtual repo. This virtual repo is actually connected to the local repositories, right? It is connected to the local repositories. So that way, when you are trying to download the Helm chart, which is technically called as a resolving the Helm chart, resolving in the sense of downloading, right? So then you ask the virtual repo, hey, virtual repo, can you give me this Helm chart? It's a virtual repo responsibility now to go and search in all the corresponding local repositories. Wherever it can find the Helm chart, it will get it for you and give it to you. That way, when you are downloading the Helm chart or when you are downloading the artifact is just a JFrog terminology, right? When you're downloading, you don't need to worry about in which local repo it is there. You just connect it to virtual repo, just get it from there. The virtual repo take care of backend, how to get it from the actual local repositories wherever it is got stored. So once you get the Helm chart downloaded from the virtual repo, just matter of running the commands on your kubectl client to deploy it into the Kubernetes. How are you doing that in Kubernetes client, guys? You just need to run Helm install command, correct? Sometime back I did, right? Helm install. Sometime back I was having the Helm chart in my local system where I have done the Helm chart creation. So I just shown you how to run Helm install. But in actual, right? So the Helm charts were created in the build server and those are uploaded to the JFrog to the local repositories. Then whenever you wanted the Helm chart to be deployed, you download that from the virtual repo and run the Helm install commands, then that will be get installed. So do you think the Helm command will connect it to Kubernetes directly, guys, whenever you are running it in your Kubernetes client? No, right? The Helm is actually taking the help of a kubectl only. So whatever the kubeconfig file that is there, that is the only way to connect it to Kubernetes. So the Helm is just taking the Helm chart, apply the values, prepare a final manifest files, then the Helm is handing over that final manifest files to the kubectl. The kubectl is the responsible guy to go and talk to a Kubernetes and do the needful stuff for you. So from our perspective, we understand that the Helm is doing the deployment, but internally the Helm is making the or using the kubectl only to do this deployment process. You just take care of converting your Helm charts it into a final manifest files format, so that your life is easier, because I'm able to make the things variabilize, because by default Kubernetes is not accepting or not helping us to make the manifest files are variabilized, right? Hence the Helm is doing that job for us here. So just to make the things a little clear out, of course, there are always some open questions will be get clarified down the line when I'm moving the things further, right? And let's say if the developer give you the code, you just go to the build server, run the commands, prepare an image, prepare a Helm chart, publish to JFrog, you are done. That means the build is completed. Tomorrow, whenever you wanted to run the application, right, just get the Helm chart from JFrog, run the Helm command, it will be done. The Helm is by default, it has its own mechanism. The Helm is by default using the kubectl that is currently configured in the same system. We don't need to tell that, hey Helm, you go and connect it to kubectl. As long as the kubectl is already installed, as long as the kubectl is already having the right kubeconfig file to authenticate the Kubernetes, the Helm can go and talk to a kubectl and make the things happen. So you just need to ensure that in which system you are running the Helm command, in that system ensure that the kubectl is already configured and it is working. That is good enough. The Helm know what needs to be done. It can talk to a kubectl and get the things done. So now, are you guys are expecting that how do we install and set up the JFrog server now? And of course, right? Now we need to set up the JFrog server, and in that JFrog server, now I need to put my Helm charts. But why do I worry about installing and setting up the JFrog server myself? You see this Docker Hub. Docker Hub is also a kind of the same behavior, right? Docker Hub is also acting as a registry where I'm going to store my Docker images. But did I install and set up the Docker Hub software? No, right? Docker Hub is called as a SaaS product, in a sense, software as a service product. That means you don't need to, right, download and install the Docker Hub related software in your own machine. No, the Docker Hub is available as part of the SaaS, software as a service model. You just go to the browser, go to hub.docker.com, just use it. So simple, right? Similarly, the JFrog also can be done. If you want, you can download the JFrog software and install it in your one of the system and configure it, make it as a JFrog server, then use it. But if you feel difficult or if you feel challenging to maintain the JFrog server by your own, right, we can get the JFrog also as a SaaS product. In the sense, you don't need to download and install and configure the JFrog. You just go to the SaaS product. What is SaaS, guys? SaaS in the sense, you just go to the web browser and start using the JFrog software. Don't worry about how the software is installed, set up for you. The JFrog people has already did it for you, right? So that's the reason if you go to the jfrog.com, right, this is where you can see the multiple products. And I wanted to use JFrog Artifactory product, right? And let's say I wanted to use a software, click on start. This is where you see the get started guide. So basically you need to create an account, right? And then start using the JFrog, right? So self-managed JFrog, in the sense you download the JFrog software and install, set it up, everything on your own machine. The SaaS product, in the sense managed JFrog. Managed in the sense they only install and set up everything for you, right? It's just matter of going to the website and just start pushing and downloading the Helm charts or any artifact that you like to. Which one do you feel better? Always a SaaS product, right? So in real time, definitely the people are started using the SaaS product only, and that's just matter of going to the website, register an account, and publish your Helm chart, download it whenever you wanted to. So easy, right? The problem is the JFrog is not free, right? JFrog is not free. It is not available as a open source version. We need to get a subscription. The only thing is the JFrog is giving the SaaS product for, I think, 15 days free trial. If you start subscribing to this JFrog, right, by filling this form, you will get 15 days trial. Within this 15 days, you can try anything that you wanted to. After 15 days, it will be get expired. You need to pay and get the subscription, then only you can use the JFrog. So just for doing the practicing, right, you just create one email ID, get the subscription, get 15 days free trial, do your practicing, then that will be done. If you really wanted to try again, create another email ID and try to get another subscription, get another 15 days free, and try to do some practice. That's how it works, right? But having a touch with one time is good enough, because nothing that we are going to do a very extensive work with the JFrog. It's a very small concept, right? So I'll try to register the account here so that at least tomorrow I can get started with this JFrog, how we can do this integration part. So I'm sure this is not the right place, I believe. Yeah, could be the one. Let me try. So I'm just using one of the email ID. It's up to you which email that you wanted to use. So now you see that there is a free trial. You see that the self-hosted trial, right? If you go to self-hosted, you will be getting the option to download the software and install and configure. It has its own steps, right? If you go for cloud trial, you'll get 14 days trial. You can explore the JFrog. I would like to go for 14 days trial, the SaaS product, and specify your company name. That means the host name. Let's say this is for ED K8s, sorry, EDX. Any name is fine, guys. Don't worry about the name, but ensure that the name should be available, right? Because with this name, they are going to give you a web URL. This is how you need to access this account, right? So the name should be in a queue, and you can give any name for the company. And I believe the phone number is optional. You see that in the backend, the JFrog is actually trying to create the infrastructure on any one of the cloud that you select here. Because at the end of the day, the JFrog also has to run one of the server, right, in the backend to store your Helm charts or any other artifact that you are uploading, correct? So they're just giving you a preference. Use AWS in the backend to create a servers on so region. This is all optional. So what is your role? My role is DevOps engineer. They're just these guys are trying to know who is creating accounts, why they are creating accounts, all these things, right? Just try now. Right now they'll set it up everything for you, right? So this is the name that I need to remember, so we can access the JFrog account. That's it. They'll take some time. Your account will be ready and it will be valid for 14 days from today. So once this is done, then we need to know how to upload the Helm chart to the JFrog, how to download the Helm chart from the JFrog whenever you need it.
You cannot upload to Git, right? It's only JFrog.
Give me a second. Yeah, so looks like my URL is ready here and you see that it's done. I need to set up the password. Let's say done. I just logged in. So this is now the JFrog account, guys. Now we'll see how to use this JFrog account later. But yeah, I just logged into my JFrog account. Now, I think that's the story for today at least, right? One other thing that I wanted to just talk about before we complete the session for today. This is all just giving some more details for you guys, okay? In general, right, in some of the big companies, right, they will be having multiple JFrog accounts. Like I created one account now, right? Like that, they will be having multiple JFrog accounts. Sometimes, you know, in a different JFrog account, there will be a different artifact is uploaded. You see, like you are working on the build server, you put your Helm charts into one JFrog. Let's say a different team is working on a different stuff. They are putting their stuff into a different JFrog account. When you have multiple JFrog accounts, right? Again, it will be difficult sometimes. The one which you are looking for may not be in a JFrog 1 account, that may be in a JFrog 2 account. How do I know which is in which JFrog account, right? So we can create a repository called remote repo in one of the primary JFrog server. That remote repository is actually connecting to the same virtual repo. That remote repository is actually connecting to the local repo of the different JFrog server. That way, right, when you're trying to download a artifact, it just connected to virtual repo. That's it. The virtual repo now take care of to get it from the local repo of the same server or remote repo which is connecting to the different server. That way, even if your file is in a different server, right, you don't need to worry, you'll get it. That's what the virtual repo is doing here. But this is just to give you the concept. What is it mean by the remote repo concept here? But don't worry, because I'm sure you will be using only one JFrog server, one JFrog account in your company, because one is good enough. Why should I be having multiple? But they have come up with these concepts too, right? So that's, I just wanted to give a small details because when you're logging into the JFrog, you always see this terminology. Then we should not get surprised. What is this remote repo? We are not using this much, right? So now coming back to the questionnaire, because I'm done for the today, right? I just giving you some overlap. And I think there will be some open questions definitely, because this is not completed yet, right? We'll be keep on doing this enhancements and further. So you may be asking me now, right? Why a JFrog again here? Like the Docker images that I'm storing in the Docker Hub. Can I put my Helm charts also in the Docker Hub? No. I mean to say, each tool has its own specialization to support you that kind of the nature. Docker Hub is the registry to store only the Docker images that is specialized for that. JFrog is the software which is specialized to store the artifacts, right? And down the line, I'll talk about Git and the Bitbucket. Those are specialized only to store the code, not for any of the other things. Like that, right? each has its own specialization, the specific purpose why these are designed. So we need to use for the same purpose only. Let's say if you ask me now the question, can I keep this Helm chart in the Git? You can, no worry. But that's not the purpose of the Git, why it is developed. Got me what I'm trying to? The Git is not designed, not developed for the purpose of to store the artifact. No. Hence, you should not. If you want, yes, there is no obstacle. You can do that, but that's not the purpose why the Git is developed. So the Git is developed to store the source code, and we use it for that only, so that we'll get more benefits. The same way the JFrog is developed to store this kind of the artifacts, so that we'll get more benefits, right? So that's how it is.